Hello, so this is a tutorial to use the Eigenharp Pico to actually play the Slim Fatty over CV using the Expert Sleeper's silent way pitch conversion possibilities. So this is going to be quite a bit technical, but I thought it would be interesting to actually go through each and every step. So what I've got here is my audio interface, which is a metric halo audio interface, which is not a DC coupled audio interface. So for this to work, you either have to have a DC coupled audio interface like metric halo ULN8 or some of the MOTU interfaces. If you don't have that, you can buy, for example, the Expert Sleeper's ES3 module that Expert Sleeper sells, and with that module you're actually able to bring in an optical audio that will then provide you with 8 channels of DC DC voltage coming out of these patch points here. So what I have is 4 patch cables going out of the Expert Sleepers interface, and these actually go into the Slim Fatty here in the back. So you can see that it goes into the control inputs here, the control voltage inputs, and it's basically on the Slim Fatty. It's gate, pitch, and then volume and filter, I think. Yes. No, it's filter and then volume. So, one thing that you might have noticed is that I switched around. So the first cable coming out of the first channel here is actually going into the second, so onto the pitch of the Slim Fatty, and the second one is going to the gate, because you will see later on that the Expert Sleeper Silent Way plugin has this the opposite way around. So that I already reversed the cables here for me to make it easy. So what else we have happening here? I've got my Eigenharp Pico that's connected basically through USB, and then I've got the audio output of, let me see here, the audio output of the Slim Fatty is going into my audio interface for several reasons. One main reason is to do the calibration so that the Expert Sleeper's Silent Way plugin is actually able to calibrate the pitch to CV conversion, and we'll get into that in a minute. So let's start from the beginning. So what I have here is, you can see this is my metric halo mixer interface. You can see my microphone coming in here. This is my, just basically my headphones. And I configured so that I've got digital output going over ADAT. And I'm using 4 channels here, so channels 3, 4, 5, and 6 that I will be able to access from within EigenD are sent to ADAT 1, 2, 3, and 4, which are the 4 channels that are available here on the ES3. And then I've got my first analog input coming back here, which is sent to the computer on a FireWire channel. It's a FireWire 3. Because I'm using the first 2 FireWire channels to actually record this video. So let's go into EigenD. So what I just did was start up EigenD without loading any of the setups. And what I'm going to use here is Workbench, which is a new tool that is part of EigenD 2, Professional. And we're going to build this entire setup from scratch. So I'm using the Create tool here to create a few agents. First of all, I want to use the Pico, so I'm using the Pico Manager, which will detect the Pico here. So we've got the Pico instrument that has been detected. And then I'm going to use a couple more agents. So first, a key group that allows me to group keys together. This goes into a scalar that basically converts key position into frequency. Then I will use an audio unit, which is going to be the Silent Way plugin. And I'm using an audio output, which allows EigenD to communicate with my audio interface. So if I use the edit tool and go to the audio, I can set it to the ULN2, which is the one that I want to use. And then I'm going to start wiring everything up. So I'm connecting the Pico to its key group and expanding it, creating a new key group output, which will be the only output that I will be using. And as soon as I've done that, I can actually now configure which keys will be part of the playing keys. So I can click with the edit tool on the key group and edit the musical mapping. So once you're editing the musical mapping, you can actually choose the keys using the Pico itself. And I'm going to create two courses. So I'm going to select the first course, so I can press the keys on the course. And as soon as I'm done, I press it a second time. So the last key that demarks the end of the course. Now I'm selecting the second course and choosing it with a keyboard also. So that's done. So you can see all these key mappings have been set up. And now you can see here a field that's course offset. So at the moment, both courses will start at the same point musically. So I can set them off an interval of 4. So this will be 4 steps in the scale. In this case, the default scale is a major scale. So these courses are set up now, and now I can connect the actual output here, the key group output, into the scaler. And you can see that it already lights up the roots of the scale on the instrument. So I've got the scaler here, which is ready to be connected later on. I'm not going to do that now. What I'm first going to do now is to actually calibrate silent way. So to do that, you need to do several things. First of all, the audio agent in EigenD is kind of the opposite way of what you're used to thinking. So the audio agent's inputs receives audio that will be sent out through your audio interface. Similarly, the outputs of the agent actually outputs audio into EigenD, which it receives from your audio interface. So if you remember, I had here my metric halo setup, which has my analog 1 input, which is a synthesizer, going out on channel 3. Now this is really dependent on the audio interface you're using. You'll probably have to look at your manual. Some interfaces have a fixed mapping where each analog input goes to a specific firewire channel. This is something you'll have to check and see how it works. With Metric Halo, I can just route it into a bus and then output it to whatever output I want. In this case, it's channel 3. So I'm going to create an output channel for the audio agent, which is channel 3. And that's where I will receive the audio that comes in from my Slim Fatty. Similarly, I've got these audio inputs here on the audio agent, which by default there are 2 of. So this is a default stereo output, which is an input into the audio agent. So output as far as your audio interface is concerned. So if we go back to the MIO console here, you can see that I'm using channels 3, 4, 5, and 6, right? So in this case, I'm going to create channels 3, 4, 5, and 6. So now to lay out everything a little bit neatly, I'm going to create a little trunk at the top here, which is going to make it a bit more beautiful. And then I'm going to configure the audio unit to actually use Expert Sleeper's silent way. So Expert Sleepers, and I've got the silent way voice controller. This is what you want. Right. So the voice controller is able to convert MIDI information into CV pitch with the calibration that's going together with it. So you can see here, if you switch back to EigenD and not to Workbench, this is the GUI of the silent way voice controller. Now going back to Workbench, you can see here that it's got several channels for audio input and audio output. So this first audio input channel of the audio unit is actually the audio output of the audio agent. So this is going to be the sound of the Slim Fatty. So I'm going to wire this into the audio input. And then I've got 6 output channels, which will, so the first one will be going into 3, the second one into 4, if you remember well from my mixer setup of my metric halo. So I'm just going to connect the first 2, so audio 1 and audio 2 going into 3 and 4. So when that is done, I can switch back to EigenD, and I can start the calibration. So what will happen is Silent Way will go over the range of voltages that it can generate, and based on what your synth accepts, in this case my Slim Fatty is volt per octave, your synth might be hertz per volt, but this is volt per octave. So it will read the audio that comes back in here on the audio input channel 1, which is the sound of the synthesizer, and it will detect the pitch that is actually being sent. So when that is done, it actually knows which voltage corresponds to which pitch. For this to work, you actually have to be careful and to configure your synthesizer so that it sends out a very pure tone. So in the Slim Fatty there is a CA calibration preset, which is very pure. It's just a simple oscillator without anything else attached to it. And this is very useful for this. So I can press this button now and it will start calibrating. So that didn't work. Let me just... So that didn't work. There's a good reason for that. It's because I had those 2 cables attached and it's not sending out any voltage. So the volume is actually 0. So let me try that again. So now it went through the whole calibration scheme. And at this point, it actually knows which voltage it has to generate for a particular pitch. So let's now go back to Workbench. So what happens here is I've got my audio going back into Silent Way, but this Silent Way audio unit is not receiving any frequency information yet. So what I'll do is I'll connect the outputs of the scalar, which generates frequency, into the controller inputs of the audio unit. So when I've done that, I can actually play the Eigenharp. So you can see this interval here that I configured. So once that is done, you actually have frequency going into the audio unit, which is converted into MIDI with pitch bend, and that is then converted into voltage by Silent Way, sent out through the audio ports here, which in my case goes out over ADAT, which goes into this Expert Sleepers ES3 module, where it goes out as DC audio, so as real voltage, into the synth here, where it actually generates a pitch and a gate trigger to actually start or stop the note. So there are a few things that we can still fine-tune here. First of all, I'm going to use a sound that's a bit more interesting. Let me see which one I had in mind earlier. Let's see if I can find it quickly. Yeah, let's see this one. So I've got another sound here. So one other thing that you have to do here is change the scalar behavior a little bit. So the scalar gets only an input for the key position now, which means that it will convert fixed pitches. Each key will correspond to a step position in the scale that the scalar is using, and then will send out a fixed frequency. Now, if you want pitch bend to work, you have to say to EigenD which information has to be used to control the pitch bend. So I'm using roll, which is the direction that goes up and down here. So I'm connecting roll into the key pitch bend input, which means that as soon as I'm wiggling the key now, I will change the pitch bend. So that's that. All right. Oh, let's go back to another patch because it doesn't work that well. Which one could we use? This one? Okay. So, next that you want to do probably is to have more control even. So you don't have to use silent wave for everything. The only real reason to use it is to do the pitch to CV conversion through the calibration. So what we're going to do now is a feature of EigenD where you can actually connect any signal into any other signal. So I can directly connect the role and yaw information to an audio output and generate CV from that. For that to be useful though, it's probably best to let it go through a ranger. So I'm going to create two rangers. So ranger 2, I will connect the output of ranger 2 to audio input 6. And I will connect the output of ranger 1 to audio input 5. Just to remember, these audio inputs are the inputs for the audio agent into EigenD, which are the outputs as far as your audio interface is concerned. So this is something that people often have trouble with. So once I've got these rangers connected, I can connect roll into the ranger 1 input. And, well, no, let's not do that. I'm going to delete this wire. Let's pressure into ranger 1 and yaw into ranger 2. Then there are a few steps that you still have to make. As far as EigenD is concerned, every signal is polyphonic. It's connected to the actual key that you pressed. So to make sure that the audio agent is receiving everything correctly, you have to set it to mono. And so pressure goes from 0 to 1, but let's change the range. Let's go from 0.3 to 1. So now you actually change the range of the values and you will never be able to get below 0.3. Similarly for ranger 2, let's set it to mono and set the minimum to 0 and the rest value to 0.5, which means that I have no voltage when I'm pressing yaw all the way down and the maximum when I'm pressing going all the way up, and in the middle I'll have half of the voltage. So this is now connected to audio input 5. And as you can see, so audio input 5 and 6. And as you can see, as I press the key, I'm actually lighting up these little lights on the ES3 as I change the control, right? So I've got 3 here, so this channel 3 is going out now. Let me just check, because so channel 3 here, that's the black wire, is not connected yet. That's why you couldn't hear anything in the audio. I want this, so this is connected to pressure, right? Which is channel 5 as far as the audio agent is concerned, and I want to connect this to the volume of what I'm playing. And then the other one, I want to connect it to the filter. So right now, I get direct connection of the pressure and the filter. So now probably this patch that I was trying out earlier will work well. Let's see. Okay, so I've got full control through voltage over my synth through the Eigenharp Pico. Now there is something else that you still can change, which is a little bit interesting. So if you go into the silent wave voice controller, you can set the pitch bend much higher. It makes it a bit more interesting. And I'm going to transpose it 1 octave lower. So you can use this detune section. Now, so this is working very well. What I'm actually using at this stage is that I'm leveraging the power of EigenD by actually using audio units for additional effects. So I'm going to, let's just move that around a little bit so that I get a little bit more space here. So I'm going to use a delay that is also an audio unit. So I'm creating an audio unit agent in Workbench, editing it again, and I'm going to use a delay that I like very much, which is the Rob Papen RP delay. So what I'm doing then is, since I'm already receiving the audio of the synth here that I used for calibration, I can connect that to the audio input of my audio unit. And then I can connect the audio outputs of my audio unit into those two channels that are still available here. And those will not be channels that are used by the ES3 to be converted into CV. These will be real audio channels. So as I collapse this back, so what I have now is an audio unit that is responsible for the delay, and it's the Rob Papen audio unit, which is this one. Now for this to work well, you probably want to set the mix to be fully wet so that you don't hear the original signal. And now you've got a nice delay going on. And so you can see the expressiveness of the Eigenharp here. This is just a single key. So I hope this was useful and that it allows you to easily set up your Eigenharp to actually play your analog synthesizer over CV. Thanks a lot for watching. Bye.